Here's a quick video on the topic that we covered at the end of class on Wednesday, having to do with Chapter 15, the acid-base properties of ions and salts. What we got through was a discussion of the acid-base properties of basically of anions, and I probably made the last clicker question a little bit overcomplicated in the way I laid out the reasoning. So I wanted to give it another shot, and we'll revisit this with cations on Friday, which are even a little trickier. The general rule of what we went over today is that an anion that is the conjugate base of a weak acid is a weak base. And so what I talked about in class was that weak is conjugate to weak. What I want to make sure I clarify here is that strong is conjugate to neutral. So the example that we considered in class for the clicker question is expanded upon here. Remember, this is a handy table to have available to you when you're doing your homework. If you are thinking about things in terms of categories of weak to weak or strong to neutral. But I actually thought of a different way to show you how to reason through this without this chart by your side. And that may be a good way to prepare for an exam. Here's an example from Chapter 15 on determining whether an anion, a negatively charged anion, is basic or pH neutral. What I want you to think about is if you're given an anion and asked if it's going to be a basic anion or basically do nothing, what you're asking is, can the anion accept a proton? So the way to figure that out is write a reaction between the anion and the proton and ask yourself if the product is a strong acid. If the answer is yes, then the anion is going to be pH neutral because the reaction that you wrote will not happen. If the answer is no, then the anion is a weak base because that weak acid that you just wrote as a product could be created in solution. I want to go through examples A and B with you to show you how this method might work for you. So the first question has to do with NO3-, that's the nitrate ion. I wrote a reaction with it and a proton, and I wrote a generic dashed arrow because I'm not committing to what type of arrow I would show yet. What I make is nitric acid. The question is the product a strong acid? Answering that question will help you answer the question from the example, which is to classify each anion as a weak base or as a pH neutral species. So ask yourself, is the product a strong acid? HNO3 is a strong acid. If we answered yes to that question, then that leads us to the conclusion that the anion is pH neutral. Now, why is that? It has to do with the arrow argument I was making in class. That arrow wouldn't be allowed to be drawn in that direction. It would be a straight arrow in the opposite direction from HNO3. So we're trying to go down a one-way street, and that's not allowed. So if that if that analogy helped you today, then that's where you link back into what we talked about in class. Let's try question B. I wrote a reaction between the anion and a proton, and I wrote a dashed arrow going to the product, HNO2. So I'm just joining the cation and the anion, and I'm asking myself, is what I got a strong acid? What's our answer here? You can tell I'm trying to choose one example from each situation. Our answer here is no. Our anion must be a weak base because what I just made is a weak acid. That means that this reaction can happen, and in fact it happens with a double-headed arrow between it, doesn't it? Because we're going from weak to weak. So I hope that helps clarify a little bit more about how we tell whether or not an anion is basic or pH neutral. On Friday we'll consider cations. We have a couple other categories of cations to consider. Some are called Lewis acids, and some are going to be similar arguments to what we have here, except we're going to see if they can basically lose a proton. Okay, see you Friday. Bye-bye.